For as long as we can remember, we seem to focus on AI models or the humanoid robots they will help power. Let's do something different this time, shall we? Why don't we take a look at these humanoid hands? After all, when we take a look at human hands, we can see how they are truly one of nature's masterpieces. Not only are they capable of carrying out some of the most powerful actions, they are also able to show the softness required to handle babies among other delicate things. In fact, they have actually been accredited as one of the reasons humanity has come so far. As such, we can see how it may be difficult for these robot engineers to put something similar together. They too want something that these robots could use to handle things with the required force or softness as required. That is why we were quite excited when we took a look at these grippers that came from Boston Dynamics. Not only does the Fourier GR1 promise strength, but it also delivers on the dexterity and the touch of human intuition that could very well make sure that the Atlas robot it is affixed to will become the standard. Join us as we take a look at how this gripper will change the way robots work forever. According to sources, Boston Dynamics' transition from hydraulics to electric when it came to Atlas gave them the inspiration they needed to get to work on their grippers. At that time, Boston Dynamics was also trying to place more focus on manipulation. They had been focusing on mobility and locomotion for quite some time at that point, and they figured that it was time to take things to the next level. To be honest, people like Alberto Rodriguez, the director of robot behavior in the Atlas humanoid program at Boston Dynamics, felt that this was the natural line of progress, as this would help them explore grippers that came with a higher level of dexterity. GR1. Despite their dreams and aspirations, they knew that their journey with the grippers was going to be a marathon as opposed to a sprint. After all, they are one of the most complex parts of the humanoid robot, and they were going to require a lot of work. Not only do they have to work on the functionality, but they would have to put in a lot of work when it comes to fixing the actuation and the sensors into such a small space. As such, you can see how this is a challenging task to complete. Despite this, Atlas and their engineers have done well to remain level-headed. They knew that this was a long-term project, and as such, they did all they could do to learn as much as they could as time went on. That is where the GR1 comes in. Considered to be the first gripper of the GR line, it was put together in a bit to create a gripper that had the most fundamental and minimalistic capabilities of the human hands that they are attempting to replicate. With his goal in mind, the creation of the GR1 allowed them to learn a lot of what it means to fix a gripper to a humanoid robot that is constantly busy, so much so that it falls. This is important because, like humans, if the humanoid robot falls, there is a chance that it's going to fall on its hands. With that in mind, they did all they could to find a way to build a robot gripper that will be able to withstand or resist that kind of failure mode. That way, they could achieve the important goal of building a robot that is rugged enough to take such contact. GR2. This resulted in the creation of the second-generation gripper. Referred to as the GR2, it comes with 7 degrees of freedom and 7 different actuators as well. All these features can be found within the 3 forefingers and the 1 articulated thumb joint. Within this second-generation gripper, you will also find that there are cameras in the palm, as well as tactile sensing on the fingertips. Another great thing about the gripper is that it is very easy to fix onto or take off the robot, and that is because the entire module is self-contained. We must note that the main difference between GR1 and GR2 is that the GR2 has a distinct thumb as opposed to the GR1 that just had 3 fingers. This is key because it allows for an increased amount of grasps in the gripper. It also increases the flexibility of the objects which the gripper can pick up or hold onto, so much so that within the last year or so, the engineers at Boston Dynamics are confident that their gripper can hold on to pretty much anything it is given. With that in mind, we must note that the reason the engineers at Boston Dynamics decided to give their grippers 3 fingers is because they figured that this was the fewest amount of fingers that they could use to get the job done, especially when it comes to manipulation tasks that are considered to be more challenging than the others. As such, we can see how those 3 fingers may prove to be the perfect design, because the distance between them could help them maintain a strong, stable grasp. As you can imagine, this could really come in handy when you are lifting heavy objects with your Atlas. On the other hand, it also allows for delicate pinch grasps. Such skills allow the gripper to handle the delicate manipulation of some of the smallest objects out there. As time has gone on, the guys at Boston Dynamics have pondered on the chances of adding some more fingers to the gripper. If such a move would add to the capabilities of the gripper, surely it is for the best, right? Despite this, they decided not to add any more fingers, at least for now, because if they do so, it makes this a bit more complex, and at this point in time, that is just not necessary. After all, not only could it lead to lower reliability, it will also make things more expensive when it comes to the development and the production of the gripper. Let's also not forget about how it will lower the speed of development that they have done well to maintain. Considering this though, they are not compelled to stick to this. After all, as Heraclitus said, everything flows, nothing stands still. And the guys at Boston Dynamics are definitely not standing still. Anything is possible, and in the future, they may very well add some more fingers to their gripper. Sense of touch. Looking at the grippers, it isn't surprising that people will wonder about how much of a sense of touch it has when it is handling objects. To answer this, Boston Dynamics have reported that their gripper has what is known as tactile sensing. You can compare it to the sense of touch that can be found in human beings. On the gripper, it can be found on the elastomers that are fixed onto the fingertips of the gripper. Upon further analysis, you'd find that they can be used to get feedback from the things it feels and be used to gauge how much force the robot is going to apply to an object. It also helps the robot know if it had dropped something it was working with. In the end, you will find that the main goal is to make sure that the gripper is able to apply as little force as possible while also being able to maintain a stable grip on whatever it's grazing onto. Right or left-handed. As to whether the gripper was left-handed or right-handed, we can say that they do have a left and right version of the humanoid hand. However, we know that they are more focused on the flexibility of the hand. For starters, it is able to rotate inward up to a 90-degree angle. However, it could be said that it surpassed the human hand because it was also able to bend backwards as well. This is perfect because according to the engineers, Atlas is designed to look for the most optimal way to complete its tasks. With hands that are so manipulatable, we can see how it is well on its way to achieving such goals. Although it doesn't have a dominant left or right hand, we know that it will use the best hand to get the work done. More evolution in mind. According to the engineers, we found that the next goal when it comes to the grippers is to focus on dexterity. To them, they figured that tasks such as bin picking or tool use is something that is very important when it comes to the manufacturing industry. Putting this together with the manipulation capabilities of the gripper and the sensing abilities of the gripper will be quite the task, but best know that the guys at Boston Dynamics will not stop until they make the perfect grippers.